Before we move on to a paired sample t-test, we need to revisit the same question that we had before between the weights of men before and the weights of women before. One of the things that we notice is that the variance in the two groups are quite a bit different. Now, this may seem a little bit trivial, but the way that we calculate the standard deviation or the standard error in the t-test statistic is just a little bit different if we have vastly different um, variations, variances. So we can see that here. The men have a variance of 3,291, where the women are only 178. So kind of imagine this, we have our women here and they're by and large about the same size, but our men have a lot more variance. So we have to take a look at whether we want to use an unequal variance t-test. According to our table, we can use the equal variance t-test if one of the three statements are true. I want to kind of add a fail-safe to this, that every time we see that we have an independent sample, let's run an independent test and test whether the variances are true. And we're going to do that using an F-test. If the sample size is large for both of them, we can get away with an equal variance t-test. If it looks like the variances are relatively close, we can use an equal variance t-test, but both of these are a little bit subjective. Let's move and take a look at an F-test for testing for variances. So an F-test is similar in a way to a single sample t-test, but what we're doing here is we're asking the question, are the variances of the two different? The F statistic is equal to the variance of the first sample divided by the variance of the second sample. And what's important here is that we want to do a single sample or a single-sided t-test. And so we're going to make sure that the top or the numerator in this fraction is the largest. So in this case we would use the men's variation in weights as the top and the women's variation in weights as the bottom. Now this statistic is the ratio of the two variances. There are many uses for the F-test. In this case we're going to be using the F-test to decide whether to use an equal or unequal variance. The statistic has two sets of degrees of freedom, one for the numerator, one for the denominator. But we're going to allow Excel to decide what the degrees of freedom are. So, the F-test and its distribution. The statistic is the ratio of the two variances. The hypothesis for the specific test is the ratio of the two variances equal to 1? And that would just mean that they're basically equal. Or is the ratio of the two variances not equal to 1? And since we define the top variance as the larger one, we're really saying as the alternative is the variance of the first higher than the variance of the second. Okay, so let's go back to our example and that we did in the last section. And before we just assumed equal variances. Now let's run a test called an F-test to actually test for equal variances. So the F-test is here, F-test to sample for variances. The input range, we're going to put the highest variance first, so we know that that's the men, and then lower variance second. We do have labels. We're going to leave the alpha. The alpha should be set as the same as your t-test. And then I'm going to put the output here on the same page. Oops. Okay. So we run this, we find the ratio of the variance of men to variance of women is 18 times. That means that the variance of men is 18 times that of the variance of women. Well, the F critical is 3.717. Now, since our F test is greater than F critical, we'd reject the null hypothesis. What does that really mean? Looking at our distribution, here's where we really are. Somewhere out on the right-hand side, we've rejected the null hypothesis. And this is the hypothesis for the F statistic. So we'd really say that the variance of the first is not equal to the variance of the second. Anywhere in this range, noting that when the largest variance is always on top, we can never get a ratio of less than 1. Anywhere in this range, we're essentially saying that the variance of the first is equal to the variance of the second. So in this range, we would use an equal variance t-test. In this range, and anything above it, we'd use an unequal variance t-test. So it appears that we have unequal variances, so I've used the wrong test for my test statistic. So let's delete this. And let's rerun the same independent t-test, assuming unequal variances. So it doesn't matter whether we put the men or the women first in this test like it is with the F test. We do have labels. And I want my output to be here. So you notice the means are the same as before. That really hasn't changed. The degrees of freedom have changed a little bit because now we have to assume that each sample is an individual sample with its individual variances. That will change our t-critical because our degrees of freedom have gone down. But we noticed from the last example that our t-stat really doesn't change too much. It's still greater than t-critical. Our p-value is still less than our alpha. So the result hasn't changed. We would still go back to the same result that we had before, and that is that the men, on average, weigh more than the women, and the business decision is that there is a statistical difference between men and women, and that there should be something done to allow for these differences or account for these differences.